So let's talk a little bit about traces. So one of the things that's most convenient to do when you're running traces is to use the legs of whatever components you have sticking through the board. So here I have a bunch of resistors and capacitors that I've stuck in, and all I'm doing is I'm bending down the legs and then routing them in a way that makes them follow the leads that I want them to. So I have a copy of the diagram of the board I'm making, and this is an inverted copy, so you'll see all the text is backwards. And I've inverted it so that way when I'm looking at the board, I can look at the bottom side while I'm running these traces and not have to invert everything in my head. I can just follow what's on the paper. So to do this, one of the things that's nice to have is a pair of flush cutters. So as components get right next to each other, you can snip them and then press them flat so they make contact, and then you can fold down the other lead flat. So that's just one way of running the traces. And then you can also put some bins in the traces if you need to go to a pin that is not straight from where you are. So a couple of these I'm going to need to do that. So this furthest one needs to go over one and then down one. So I can go ahead and do that. And the way I do that is I take the pliers, I place them beside one of the holes, and that's because there's a bend radius on the components. And then I just bend it to get a nice sharp 90-degree turn. And then I do that one more time to get it to come down where it needs to be. And that gets you nice corners that are able to follow the grid pattern on the board, which just makes it easier to make sure you're not crossing over different pins and making contact with some stuff on the other side. Another thing you can do is if you have places in the board where you need the board to pop out because you have to cross some wires that are on the bottom, you can come to the top side and cross over. If you do that, it's good to keep it the wire insulated, so that way if you have through holes that are plated, so like these, you can see there's plating on both sides. If I made contact on the bottom side with a wire and then on the top side there was just bare wire laying across that, the two might short together. So here I'm going to place a wire that does that, and here it's not because I have wires that are crossing the other direction, but this is because this component, this back plate on it, is connected to one of the signals, so in this case ground. So if I ran that wire right underneath there, what would happen is there's the potential for that plate to short against the top of these, so I don't want to run bare wire underneath it. So I've created this jumper that runs on the top that's insulated because of that. And to create these, what you can do is take the wire that you're going to want to use, strip one end of it, and then go how many spots you want the wire to jump. So this one I'm going to need to use has to jump 2 holes. So I place the edge of the insulation at 1 hole, and then I count over the 2 holes I need it to cross. So 1, 2, and then the next hole over, I just put a little nick in the insulation, and that tells me where I need to strip it. So then I can go ahead and cut this, and because I'm going to need to run a trace after this a little bit, I leave one side of it a little long, and that's just so I can run that trace afterwards. And here the insulation helps stiffen one of the portions, so you can still bend it and get a fairly nice sharp corner on it. And then you can go ahead and place that in the board, jump over the wires you need it to jump over. So this one is going to go right here. Well, one of these components is off in its positioning, so I'll go ahead and fix that, and then we can continue.